Alright, so here we are with Unit 9, Lesson number 4, and we're going to start to get into the different theories about acids and bases, and there are two theories. One is called the Arrhenius acid-base theory. The other one, which we'll do later on, is called the Bronsted-Lowry theory, but for the most part on the Regents exam it's referred to as the alternate theory. Um, the Arrhenius theory is one way of defining or identifying a substance that acts as an acid, has the properties of acids. It's a completely different definition than in the alternate theory. So let's take a look at the Arrhenius theory. Basically, and this is one of the definitions that you should remember, is that an Arrhenius theory, an Arrhenius acid is defined as any substance that, when dissolved in water, produces H plus ions as the only positive ion. And in essence, what that means for the most part, and this is what they're talking about down here, an Arrhenius acid, for the most part, is going to be, if you look at this rule down here, is going to be any compound that has hydrogen as the first element. So anything that has H first, and there are a couple of exceptions to the rule, but any compound that you see on the Regents exam, and I mean any compound that you see, other than water and one other compound, hydrogen peroxide, that has H first is going to be an acid. It'll sometimes be in binary acid, which means you have two elements, one of which is hydrogen. Could be a ternary acid, which has three or more elements. Notice that both of these have H written first. They are both going to be considered an Arrhenius acid. I'm sorry, and what these acids produce when they dissolve in water, or they mix with water, is they break apart into H plus ions and then whatever the negative ion happens to be. Notice that this acid breaks apart into two H pluses. That's why the formula has H2 in it as opposed to just HS, and then it's negative ions. And that's what this rule at the bottom is talking about here, about the general rule for acids, or Arrhenius acids. This is extremely important, and this is what I was just talking about. There are a couple of exceptions to that rule, and one of the exceptions would be water is an exception, as is H2O2. These are not acids. Now, if you look at this and this, these are not acids either, and they don't even come close to the Arrhenius rule, right? For a couple of reasons. When you put methane or glucose in water, it never is going to produce an H plus ion, nor will the ammonia. So none of these five are acids, and even though water and hydrogen peroxide have H first, they are not acids either. And that is the Arrhenius theory of acids.